This is another one of my short videos regarding bad engineering from construction equipment manufacturers such as Case, John Deere, Mustang, and all others, including those foreign-made. As I have indicated in my previous videos, build them so that they can be easily repairable in the field. So anyway, this is a repeat with more detail. With that, let's get started. First off are the most troublesome of all are the hydraulic cylinders. Not that they do not work well, they do. It's that the majority of them are difficult to rebuild, take apart, or remove. There is no excuse for that. These are not flying aircraft that require such tight tolerances. The only areas on the cylinders that require strict adherence to tolerances are the internal parts such as the piston, rods, and cylinder walls. Period. That's it. Everything else on the exterior should be manufactured with plenty of clearances. In the first image I show a typical Case backhoe stabilizer cylinder showing a close-up of the gland. Who is the idiot from Case Engineer that designed this thin of a gland lip edge? Anyone that has used a gland removal tool knows that it only works on a fairly new piece of equipment. Those small 3/8 inch holes in the gland face surface that are supposed to fit in rarely do a good job of standing up to the heavy torque that the original gland was installed to. The holes often deform and become useless, causing the person doing the repair to revert to using a good old-fashioned pipe wrench, which is what I did. My altered photo shows a better gland cap that is thicker and fatter. There are cylinders made just like it. Wake up. As an alternate, a person might try welding a couple of thick metal ears to the gland face to ease removal. There's no excuse for thin gland, assholes. There's plenty of room there. And what's with the stupid number 10 security screw on the gland edge supposed to stop? Must I remind you, this is not an airplane. Any moron can tell immediately if any of his glands become loose. You don't need to add additional fasteners. As a matter of fact, after replacing the seal on the one side, you'll notice I never tighten it to its original position, so I can remove it easily next time. And it never leaked after 3 years now, proving you guys that build this stuff don't know your systems. By the way, I'm an ex-tool and die maker myself. Next I'll mention the cylinder mounting pins. Again, who is the idiot engineer that designed the pin to have only 1/1000th clearance? How is a person in the field supposed to remove one that is a few years old and rusted into place? It becomes a nightmare that should never happen. Pins should need anywhere from 5,000 to 10,000th clearance. From the photo I can tell you that I used a sledgehammer, all kinds of penetrating oils. I even ordered some I didn't have, and none of them worked. Not even heating them caused them to loosen. I ended up purchasing a blowtorch which could only work after sewing the pin in 2 places, which allowed me to remove the cylinder for repairs. Even then, using a hydraulic button, I could not budge the 1 inch or so section out. Even after heating the little pieces with my new torch, so I ended up drilling a hole in each, starting with an 1/8 inch drill up to a 1/4 inch. Then I was able to burn through the pin as you see in the photo. I replaced the new pin after grinding it down a few thousandths and adding my own grease fitting. Shame on you idiots that build such friggin' crap. I'm referring to you Case people for now. If you people that manufacture this stuff watch some of the YouTube videos, you would learn something. There's a heck of a lot of people that are having trouble with these pins stuck in place and having to use all kinds of torches to get them out. That is shameful of you people. Next, I mentioned the water infiltration. Whenever a hydraulic cylinder is designed with the rod tilted upwards, it's going to allow condensate and rainwater to seep in. The gland seal does a good job with the oil, but sucks keeping the water out. That is why I added rags and plastic bags around the glands whenever I park my equipment. Otherwise, the hydraulic oil gets milky from mixing with water. Even after allowing the oil to sit for 1 year, I noticed the water never settled out, and that's because of the difference between hydraulic oil and motor oil. Hydraulic oil is designed to absorb water so that the water does not freeze in the lines, causing them to break or clog. If you ever wish to reuse milky hydraulic oil, simply boil it until you get it up to 230 degrees or so. Yes, it works. There are several methods you can use, from a turkey fryer to simply plugging in a hot water electric heating element into a steel bucket of oil. It takes roughly 4 minutes of boiling for 2 gallons of oil. Notice that I parked my backhoe extended so that the cylinders point downward. Also note that the supporting legs are down too, all to prevent water seeping in. In the new backhoe model, the same mistake is made when they design the cylinders to point upwards on the sides there. Next, I show a close-up of the various oil canister filters. Notice that most of them have mounting brackets that are smaller in diameter than the filter itself. Keeping the filter in a vertical position allows water to collect and eventually rust through. I've had cases where I lost much of my oil because there was no way of telling with the side panels on that I had a leak. Condensation over time was the culprit. A better method is to mount them similar to the way a car filter is mounted, horizontally. Yes, there will be some oil dripping during the filter change, however small in comparison. Some kind of cover would help, including adding plastic wrap for now. Next, I show how I saved hundreds of dollars by not replacing the original radiator for like $450 or $500 when the hydraulic return portion began leaking. I purchased a $50 oil cooler instead and piped it up with some modifications. I could have simply used one of my Chevy pickup truck's water heater core, and I could have simply done away with the hydraulic cooler also, since my equipment ever gets hot, since I use it very little. Some simple stuff that needs mentioning. Why does the hydraulic oil fill cap have to be so small in diameter and have those ridiculous dipstick tags? A 3 or 4 inch cap would be nice, like those used on excavators. The same for the dinky fuel cap. Both of them could use a screen also inside. The front bucket has no way of telling when the bucket is level with the ground. An operator should be able to visually see and not rely on some sensor not working. And finally, get rid of those silly switches that disengage the transmission and connect it directly to the brake light switch like it should be. Thank you for watching. Give it a thumbs up if you can. Visit us at LarryandJane.com.